When we factor, we're pretty much going to reverse what we just did in FOIL. So if you recall the previous example, we had the 4x squared minus 1x subtract 18. So we would be taking that expression and going back up to the two binomials that we ended up multiplying. So one of those ways to factor is called the British method, and there are 6 steps to follow in order to do that. So first, you want to factor out the greatest common factor. If all 3 terms have a number in common, or if they have a variable in common, you want to get rid of that before you do anything else. Then we're going to multiply our A times our C, so that's going to be the first term times the last term. Then we're going to ask ourselves what 2 numbers would equal that product, and that will also add up to give me my B term. So that's where we're going to hit some issues. That's the tricky part. And you want to be careful and watch your signs. Then we're going to write our leading coefficient A with an x in front of each of those 2 factors we found. So we're going to start building those binomials. And then if we can, we're going to reduce those sets, each one individually. So one may reduce and one may not. And then you can always go back and test your answer with FOIL to make sure you get the correct equation. So let's look at an example. So in number 1, I have 3x squared plus 10x plus 7. So the first step is to check for any greatest common factors. So between 3, 10, and 7, they have nothing in common, and they don't have any variables in common either. So I'm going to go to step 2. So that's taking my A term times my C term. So remember, your A term is the 3 and your C term is the 7. So I'm going to multiply 3 times 7, and that gives me 21. Now in step 3, I'm going to look for 2 numbers that multiply to give you 21, but they have to add up to your B term, and here we have 10. So if I look back up at 2, I know that 3 times 7 gives me the 21 that I need. But 3 plus 7 also adds up to my B term of 10. So my 2 factors will be 3 and 7. Now that does not always happen. So what you multiplied for A times C does not always end up being the same 2 numbers that you used for number 3. So now in step 4, I want to take my A term with an x and put it in front of the 3 and of the 7. So my A term was also a 3. So in my first set, I'm going to have the 3x with the factor of 3 that I found. And then in my second set, I'm going to have 3x as well with the factor of 7. Now in step 5, I want to see, can I simplify either one of these sets? Now remember, one may simplify and one may not. Or they both may simplify. Or they both may not. So if I look at my 3x plus 3, they both have the number 3, so I can divide both of those numbers by 3. 3 divided by 3 is a 1, so I'll be left with a 1x. And the other 3 divided by 3 is also 1, so I'll have a plus 1. So 3x plus 3 simplified down to x plus 1. If I look at 3x plus 7, 3 and 7 have nothing in common, so I'm just going to bring down that last set of parentheses. So that's our final answer. So 3x squared plus 10x plus 7 factors down to give us x plus 1 and 3x plus 7. Now we can check our answer by repeating the FOIL process. So if I want to, I can FOIL. So I'll take x times 3x, and that would give me 3x squared. X times 7 would give me a positive 7x. 1 times 3x would give me a positive 3x. And 1 times 7 would give me a positive 7. So when I combine my like terms in the middle, I'll end up with 3x squared plus 10x plus 7, which matches the equation that I started with. So my answer in number 5 is correct. So I'm going to do the same thing in number 2. So remember, your first step is to make sure that you don't have any like terms. So between 2, -3, and 20, I don't have anything in common. The 2 and 20 do, but all 3 of the terms have to be able to divide by the same number. So in step 2, I'm going to multiply my A term times my C term. So 2 times -20 will give us a -40. So now in step 3, I need to find two numbers that are going to multiply to give me negative 40, and they're going to add up to give me negative 3. So if I look back like I did in the previous one at step 2, and I look at my numbers of 2 and negative 20, if I add them, they're going to give me a negative 18. So it's not going to work this time. So I'm going to have to think of other numbers that multiply to give me a negative 40. So what may be helpful is to make a list off to the side of the numbers that will multiply to give us that 40. So we know 2 and 20, but we already rolled that one out. 4 times 10 will give me 40, but if I add 4 and 10, it's not going to give me 3. I then know 5 times 8 gives me 40. So I can look here, and can I get a negative 3 if I change one of those signs? Okay, and I can. So if I would make my 8 negative, 5 plus a negative 8 would give me a negative 3. Okay, I know the difference between the 8 and the 5 to be a 3, so at that point I can just change my signs to accommodate to the number that I want. So my two factors here will be a positive 5 and a negative 8. Because when I multiply, they give me negative 40. When I add, they give me my negative 3, which is my B term. Now in step 4, I'm going to take my A with the variable n and put it in front of each factor individually. So I will have 2n plus 5, and I will have 2n subtract 8. Now I'm going to see if these simplify. If I look at 2 and 5, they don't have anything in common, so my 2n plus 5 will stay the same. And then I have a 2 and a negative 8. Both of those numbers can divide by 2, and it'll give me an n subtract 4. So like I did in the previous problem, I can always check with FOIL to see if it works out in the end.